Hello everyone. Alright guys, this is the review for the test. I can print this too if you need the notes. So we're just going to scroll through it here. Alright. Guys, again, we looked at measures of central tendency, mean, median, mode. Alright, they describe the middle of the data. We look at measures of spread. They describe the edges of the data or how the data varies from the center. Standard deviation, the IQR, the interquartile range, and the range. Guys, looked at a box and whisker plot. It displays the 5-number summary for a set of data. All right. And these percentiles, the 25th percentile, 50th, 25th and 75th. And that's where the interquartile range comes from, Q3 minus Q1. Again, the exact mean cannot be determined from a box and whisker plot, not necessarily. There's a 5-number summary again. This is straight up and down. The box and whisker plot is straight up and down here. Okay? Shows all the percentiles right here. The full range of the data. Alright guys, the dot plot, it shows every value in the set. It shows the clusters, the gaps, and the outliers. If you need to know about an individual data point, use a dot plot. In a histogram, it does not show individual values. Not a histogram. The data is organized into intervals or bins, buckets, but intervals. Small little ranges. All right, each bar in the histogram displays the frequency, the number of times a data point occurs within that interval, within that little mini range. And if you need to know how many data values occur in some interval, you're interested in looking at some interval, use a histogram. It's when you don't need to know within the interval just how many are in there. Again, histograms do not display individual values within each interval. You cannot determine the exact minimum or maximum values from a histogram, not exactly. You cannot determine the exact mean or median from a histogram unless sometimes you can if it's if the interval is 1 and you can count. So it's kind of like a dot plot in a way. Sometimes it looks like that and you can just count, all right, and get the mean. All right, again, we talked about symmetry. When the shape is symmetry, both tails are the same size and length. And half the shape is close to a mere reflection of the other half. Data values are evenly spread on both sides. Then when it looks like this, the mean, median, and mode are almost the same. It's balanced on the left and the right. As in one tail of the data is longer than the other, the data is said to be skewed. We talked about this. It's unevenly spread on either side of the center. All right, this one is skewed left. All right, the skew goes toward the tail, just like this, skewed left or right. The direction of the skew follows the direction of the longer tail. Guys, when the data set is skewed, the mean of the data is pulled away from the median toward the tail. All right? The median moves a little off the center. It might, right, because of these values up here. But the mean definitely will be pulled away from the median. Again, we talked about uniform. That's when we rolled one dice. All the data in the set occurs at about the same frequency. It's almost a straight line across the top. It doesn't have to be perfect, guys, but you need to understand this is not a normal distribution. It's not bimodal. It's, so you can recognize what that is. It's not always perfect. Again, we have two modes. That's bimodal, like that. Two separate modes. And normally they're on one side or the other, okay? Where the middle kind of disappears. Now we talked about normal distribution. Okay, it's a symmetric bell-shaped curve. All right, an example of a set of data that's normally distributed is right here. We have 1, 7 on the outside here and 1, 13 on this side. And then 2 12s and 2 8s. 3 9s and 3 11s, okay? And then there's 4 10s in the middle. All right, that's a normal distribution. And when data is normally distributed, the most useful measure of spread is the standard deviation. All right, it's a measure that shows how data varies from the mean. Okay, and it kind of quantifies. We can go 1 standard deviation, 2 standard deviations, okay? Again, normal distribution shows data that varies randomly from the mean, shaped like a bell. It's 50-50 on each side of the mean in terms of how many data points. And the mean, median, and mode are about the same. All right? It's a very important part of normal distribution right here. Okay, let me get myself out of the way as you can see it. These percentages. Again, 1 standard deviation away from the middle, from the mean. 68%, 34 on each side. All right, then 2 standard deviations, you get 95% right there. So there's 2.5 left on this side and 2.5 left on this side. We talked about that. And 68% within 1 standard deviation, 95 within 2. And guys, just so you know, it's like 99.7 within 3. Almost certainty within 3 standard deviations. Not always, but I keep moving myself around here. All right, that's it. End of the notes, guys. I appreciate it. Thanks. That's a good review for the test.